Our next unit of notes is going to be covering the same material that our textbook covers in the next chapter, in chapter 4, which is about congruent triangles. But instead of covering it from our textbook, we'll be covering it from our note sheets, and then all of our homework will be coming from another packet of worksheets. So you're not going to need your textbooks for about the next 2 weeks.
2 weeks.
So as far as our quarter goes, and wrapping things up, yesterday's quiz was the last quiz or test that will be on this quarter. So over the next week and a half, the only thing that will be happening to your grade is assignments. And then also any corrections you want to do to tests or quizzes that we've already taken. But the only new things going in to wrap out your quarter grade are going to be the assignments from this unit. This test won't happen until after the next quarter starts. But you don't have to bring your textbooks to class for about the next 2 weeks, or home or anywhere else. Wherever they are, they can stay there for about the next 2 weeks, and all of your assignments are going to be coming from the notes and then from another packet of worksheets. So in these lessons, we're going to be talking about some congruent triangles, and we're going to start today with an acronym or abbreviation that is fun to say. It's a little bit of a tongue twister, but cpctc. And it's really important that when you use acronyms, you should know what they mean. It's a pretty bad thing to just be like throwing out letters and have no clue what it is you're saying. So we had a lot of letters before in the last chapter, things like AIA and SSIA. It's a good idea to know what those things stand for, right? So CPCTC stands for corresponding parts of congruent triangles are congruent. A lot of big words in there. Basically what we're going to be looking at in this whole chapter, or unit of lessons, is two triangles that are exactly the same in every way. So that means that they are congruent. And if two triangles are exactly the same in every way, that means I should be able to find some matching parts and say this angle should be exactly the same as an angle in the other triangle because the triangles are exactly the same. So what CPCTC means is that if two triangles are exactly the same, I should be able to then find all the parts and pieces to match up from one triangle to the other one. We're going to have a lot of acronyms in this chapter, so it's going to be a good idea. It's going to be important to make sure you know what those mean. I don't mind at all using acronyms and abbreviations, but you need to make sure you know what you're saying. It's a good general rule in life, too. I see a lot of students saying things on Facebook that I really hope they don't know what they mean, because if they do know what they mean, they're saying things they shouldn't be saying. So we just want to make sure we know what our abbreviations and acronyms mean when we're using them. So what we're going to be doing is setting up a relationship between two triangles and then setting up the relationships of all of the matching pairs of angles and sides. All of your problems today are going to be the same type of problem. All of the problems today are going to require 7 answers. The first answer is going to be that we are going to name the two triangles. Then we're going to match up all 3 sets of angles and all 3 sets of sides. So for each problem that you do today, you will have 7 answers. So the first thing we want to do is match up the triangles. When we name a triangle, we use a little triangle symbol. And then I can name my first triangle whatever I want. Just use the 3 letters, any order, start anywhere, it doesn't matter. So I'm going to call that first triangle DCO. That's the top one. You can call it DOC, you can call it COD, it doesn't matter. You name your first triangle whatever you want to name it. But once you have named your first triangle, the name of your second triangle matters. Because the way we name it needs to show the relationship between the two triangles. So I'm going to say is congruent to triangle, and now I need to select these letters carefully in such a way that the letters are matching up appropriately. This is the only lesson where I'm going to tell you you can trust your eyes and just go with what it looks like. So what angle looks like it is the same as the angle at D? B. So that has to be the first letter. Since D was the first letter, we need to find the angle that looks like it's the same as the angle. So B and D look like they're the same. Then it says C. What letter looks like it has the same angle as C? A. And then that only leaves O. And actually the 2 angles at O we can know are congruent. They don't just look like they are, but we can know it. Because what kind of angles are they?
Vertical.
Vertical angles. Okay, so that's actually a fact that we can know for sure. We're not trusting our eyes there. But in the other ones, we're just going to trust our eyes and say B looks like D, A looks like C. Okay, so that's first step is name the triangles. I think that's actually the hardest step, okay, is trying to find that relationship. Then we want to name the relationships of the angle pairs. So I'm going to name an angle in the first one. There's an angle at D. I can use just one letter here because when I say angle D, you all look to the same place. There's only one thing happening at D, so it's okay to name it with a single letter. You can use 3-letter names if you want, and that's fine, but I like using single letters when I can just because it's shorter, and I'm kind of a lazy person like that. So what angle looks like it's the same size as D? B. Then I have an angle at C. What one looks like it's the same size as C? And then I cannot say angle O. That's a problem because there are actually lots of angles at O. There's some acute angles, those verticals that we referenced inside the triangle. There's obtuse angles because there's the big angles that are kind of outside the triangles. There's straight angles because we can always just draw a straight line and call it an angle. So we can't just say angle O because there's too much happening there. So then we do need to use 3-lettered names. So I'm going to call that first one in the top triangle angle DOC. And that's the same as in the bottom triangle then, angle BOA. Okay, so you can use a single letter when there is no doubt about what angle you are talking about. But if I say angle O, you don't really know what I'm looking at, so then we can't use a single letter. Then we have to use 3 letters. Okay, so we name our triangles, we name our angles, and then we need to name our sides. If you have already named your triangles, naming the sides is the easiest step because we can just steal the side names right from the triangle names. So what I'm going to do is take the first 2 letters and say they should be the same as the first 2 letters. So DC should be the same as BA. Order matters, so keep them in that order. DC is the same as BA. Then I can take the second set of letters, CO and AO. And then the final set is taking the first and the last. DO and BO. So once you've named the triangles, naming the sides doesn't even require looking at the picture. You can, it's probably a good idea to make sure that it at least looks like we're talking about the right kind of things. That DC is the side that looks the same as the side BA. That CO is the side that looks like the same as the side AO. And that DO looks like it's the same as BO. This is probably a good idea to look at your picture and make sure. But if you've already named your triangles, naming the sides, you can just steal the names right out of that triangle name. So for each of your questions today, you're going to have 7 answers. Name the triangles, name the 3 sets of angles, name the 3 sets of sides. Questions? All right, let's try this one. So one thing I like to do in my pictures when I start out is maybe mark up what's the same. So the last one we just kind of referenced it. They were completely separate, so it's a little bit easier to see. In these triangles, it might be helpful if we kind of mark up what's the same. So what angle is going to have to be the same size as angle 1? 3. Angle 3. Right now, we're just saying they're the same because they kind of look like they're the same. But if I was given some information about some parallel lines, then those are a special angle pair for us. What kind of angles are those?
AIA.
AIAs. Okay, alternate interior angles there because they kind of make that zigzag. Those old angle pairs that we talked about with parallel lines, they're not going away. Okay, they were in the last chapter, but geometry is very cumulative for this first semester, so we're still going to be working with those old angle pairs here. Okay, so 1 and 3 look like they're the same. What looks like it's the same as 4? 2, which would mean by process of elimination, P and R look like they would have to be the same then too. So now when I name my angles and my triangles, I can name my first triangle whatever I want. So I'm going to name that top one PAL. Then when I name the second one, it starts to matter. So first one you can do whatever you want. Second one you have to be careful. What angle did we say was the same size as P? R. Now for A, when I named my top triangle PAL, the angle at A is angle 1. What angle did we say was the same as 1? 3. And what letter is that by? L. So that means our next letter has to be L. By process of elimination, we can figure out what the last one has to be, but to go through that process again, in the top triangle, the one we already named PAL, L is by angle 4, which is the same as what? Angle 2, which is by letter A. So then that letter would have to be A. Okay. So first one, name whatever you want. Second one, make sure you're matching up the letters that would match up. Questions on naming the triangles? Let's name the angles then. I can say angle P because there's only one angle by P, and that's the same as what angle? The angle by R. We cannot say angle A or angle L because there's too much stuff happening there. If I say angle L, you don't know whether I'm talking about 3 or 4 or the whole thing. So we can't say angle L. But we can use number names, and I suggest if numbers are in the picture, using numbers. You could use 3-letter names. It is easier to just use numbers, and that'll make it easier when we grade our homework if everybody's doing the same thing there. So I'm going to use number names. So angle 1 is the same size as angle 3, and angle 4 is the same size as angle 2. Okay. You could use 3-letter names on those and call them like PLA, but it's probably easier to just grab the numbers. All right, then we need our sides. Sides, again, we can just steal right from our triangles. So PA has to match with RL. Then the second set of letters, AL, matches with LA. And then the first and last, PL, matches with RA. Order matters. Okay. Yeah.
When we're writing our homework and stuff, will it be marked down if we write equals instead of congruent?
No, I'm not gonna be super picky about the equals and congruent things. Technically, if we're talking about a shape, it should be congruent. If we're talking about a size, then we say equals. But I'm not gonna be. I mean, if you forget the little squiggle, I'm not gonna be really picky about that. One thing I want to point out in this one is that as we move through this unit, one thing we're going to try to visualize is how we could make these two triangles completely line up. Because if they are exactly the same size, I should be able to some way set them on top of each other and have them like one completely cover the other if they're exactly the same. And there's kind of 2 main ways we could do that. One way is by a folding. If I thought about folding my paper down that middle line LA, those 2 triangles are not going to line right up. Okay, folding wouldn't work here. What would work to get that top triangle to land on top of the bottom one is turning it around or rotating it around. When we have that rotating or twisting, something we're going to notice in our sides is that one of our sides is going to say the same thing but backwards. Okay, so that middle line is in both the triangles, but it's backwards because I have to twist or turn around the triangles to make them land on top of each other, as opposed to a folding.
Couldn't you just flip it over AL?
If I just fold it over AL, things are not going to line up appropriately. If I thought about folding my paper, the points aren't going to land right on top of each other because point P would be down here and point R would be up there. They're not going to land right on top of each other. All right, for our last example, to visualize this one, I'm thinking kind of like a book. Okay, I've got 2 planes that are coming together. Each of those planes have a triangle on them, and they share kind of that middle line. So I'm thinking this is kind of like a book, and I could just close up that book, and those 2 triangles are going to land right on top of each other. So this is a folding one, that I would fold to close my book, and those 2 triangles are going to perfectly match up and land on top of each other. So to name the triangles, Triangle, I can call the first one whatever I want, ABD. Congruent to triangle. When I fold close that book, what letter is A going to match with? C. What letter is B going to match with? B, because when I fold close the book, the crease doesn't move. Right? The crease stays right where it is. And D will likewise match with D. Okay, so this is different than the last one, that it doesn't have that twisting. That middle line is just going to stay exactly that middle line, and points A and C would come together. Questions on naming the triangles? Okay, so then naming our angles. I've got an angle by A, and I can just call it A because that's all that's happening at A. And then what about at, what would match up with that? C. I've got an angle called 1, and what would match up with that? 2. And I've got an angle called 3, and that would match up with 4. Because when I fold close the book, those are the angles that are going to land on top of each other. Questions about the angle pairs? For side pairs, we can just grab them right from our names. AB, CB. Second pair, BD, BD. And outside pair, AD, CD. Yes, question.
Wouldn't it be BD and DB like it was last time?
It would not be. So in the last time, the letters of the one that were the same were flipped backwards. And the reason that was because to make those two triangles line up, I had to twist them or turn them or rotate them to make that happen. Whereas this one, our book is folding closed. And so that fold line isn't moving. When I fold the book closed, the only thing that's moving are points A and C. Okay? So in this one, when we have a folding, we're going to notice that our name that's the same is actually exactly the same. As opposed to in the last problem, when we have a turning or a rotating, our name that's the same is going to end up backwards, AL and LA. Okay? Other questions? All right, so your homework, again, is going to come from a packet. It's actually not quite these numbers. Your sheet is correct, 5 to 9 and 11 and 12. What it says on your sheet is correct. On 5 through 9, you're going to have your 7 answers like we did. Okay, name your triangle, name your angles, name your sides. On 11 and 12, they actually name the triangles already for you. So then you're just going to have 6 answers. Name your angles, name your sides. Okay? All right, and I will pass out that packet.